Oh, that's what's missing. Okay, here we go. Today we are doing a review of geometry in Algebra 1. Yay for us. So, the first thing that we're going to review is the Pythagorean Theorem. Shout it out. What is the Pythagorean Theorem? A squared plus b squared equals c squared. Excellent. What does that refer to? A, B, and C represent something in something. What are they? Kendra? What? Parts of a triangle. Okay. So any triangle, I can draw that up there and that'll work? Right triangle. Ah, good. Okay. Right triangle. Excellent. Everybody give it up for Kendra. Okay, within a right triangle, what goes where? Lydia.
A and B will be on either side of the right angle.
Okay.
And C is the hypotenuse.
Cool. Everybody give it up for Lydia. Okay. Next thing that we're going to review is the midpoint formula, meaning if we have in a graph 2 points anywhere, doesn't really matter where. Let's say the 2 points are here and there. If you want to find the midpoint or the halfway point between those 2 points, so point 1 and point 2. So if point 1 has coordinates x1, y1, and point 2 has coordinates x2, y2, the way that we find the midpoint or the halfway point between the two of them is you take the x coordinates and find the average of the two of them. So add them together and divide by 2. Since it's a coordinate, we have for each coordinate we have an x and a y, right? So the x midpoint is x1 plus x2 divided by 2, and the same with the y coordinates, y1 plus y2 divided by 2. So that is the midpoint formula. Does that look familiar? No. All right. Well, so this is brand new. That's okay. Pretty easy. Okay, and then the last one, distance formula. We're going to use the same graph up here. The distance formula, we've used distance equals rate times time before. This is a different distance formula. This is saying if we have points P1 and P2, the actual distance between the two of them is a certain length. Okay, so for points P1, which is x1, y1, and P2, which is x2, y2, the distance between the two of them is x1 minus x2 squared plus y1 minus y2 squared, square root of all of that. Okay, so we are going to use each of these things today. We might not actually use the Pythagorean Theorem in our notes, but you may have to apply the Pythagorean Theorem to a couple of problems in your homework. Okay, questions on this? Does everybody have this on their paper? We only have 4 examples, and they're really short. We good? All right.
No, I don't have it.
Okay, so for the first set of examples, for the coordinates D, which is at -2, 1, and F, which is at 4, -5, we want to find the distance between points D and F. So, how do I do it? So if D is -2, 1, and F is 4, -5, how do I find the distance between those 2 points?
I got it.
How do I do it, Jade?
How do I?
Oh, you got that. Okay. Okay, so I actually just took it off the screen. So distance formula is what? You just all just take what? x1 minus x2 squared plus y1 minus y2 squared. Is this familiar? No, really? That could be it. Okay, so we have, let's just say because D is the first one listed, that D is x1, y1. So there's our x1, there's our y1. And F, which is 4, -5, that is our x2, y2. All right, so somebody plug these in for me into this distance formula. What goes where? Akash. Okay. Good. And then what's in the next one?
Oh.
Go ahead. Yeah, go ahead and keep going. 1 minus. Cool. Everybody give it up for Akashni. Okay, double negatives turn into a what again? Positive. All right, everybody shout out, what is negative 2 minus 4? Negative 6. And what is 1 plus 5? 6. What is 6 squared? 36. And what is negative 6 squared? 36 plus 36? 72. Wow, we are all really enthusiastic today. Okay, so can anybody think, if we want to simplify this, so how would we simplify the square root of 72? Kendra? 9 and 8, okay. So that's the square root of 9 times the square root of 8. What's the square root of 9? 3. So 3 root 8. Can we simplify further? Yes, we can. Square root of 8. I almost said Maxie. Marcy. 4 and 2, good. So 3 root 4 root 2. What's the square root of 4? 2. So it's 3 times 2 root 2, which is 6 root 2. Everybody give it up for Kendra and Marcy. Okay, the next one. We are finding the midpoint, or the halfway point between the same 2 points. So we still have D, which is at negative 2, 1, and F, which is at 4, negative 5. So look back to your notes that we just took, and the midpoint formula. How do we find the midpoint of these 2 points? Yeah, Jade.
x1 plus x2.
Good.
So negative 2 plus 4.
Good.
Over 2.
Uh-huh.
And then y1. So 1 plus negative 5.
Cool. Everybody give it up for Jade. Okay, so negative 2 plus 4 is what? 2. Good. And 1 plus negative 5 is?
4.
That's negative 4. Okay. 2 divided by 2 is? 1. Negative 4 divided by 2 is? Negative 2. So the halfway point between those 2 points, if we were to put those points on a graph and then draw the midpoint, it should be right in the exact middle of the other 2. Questions? They're relatively straightforward?
Yeah.
Cool. Okay. Last 2 problems. There are words involved. Oh, Lord have mercy. Okay. One endpoint of a segment is at negative 8, negative 12, and the midpoint is negative 4, negative 2. Find the coordinates of the other endpoint. There are so many ways to do this problem. But does anyone have one way that we could go about doing this? So again, if we were to think about graphing these, negative 8, negative 12 is down and to the left. Negative 4, negative 2 is also down and to the left. We're looking for the other endpoint. Lydia? Yeah, you can just graph it. Let's get, all right, if we want to do the graphing way, since, do 1 and 1 here. Okay, so if we want to graph, all right, negative 8, negative 12, what do I do? Go ahead, Lydia. So she's giving me one way of doing this. How do I get to negative 8, negative 12? Okay. 4, 8, 12. So there's the first, that's point 1. Okay, then it says the midpoint is at where? Negative 4, negative 2. So that's the midpoint. So there's another coordinate somewhere out here that is the other endpoint of this segment. Sorry, I just realized you can't see that. Okay, how do we get there? If we have these 2 points, go ahead, Lydia.
You find the slope, and then you can go.
Right. Perfect. Okay, so the slope, meaning to get from point P1 to M, we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and write 4. So to get to the other endpoint, we go up 10 and write 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. And that is point 2, which is at 0, 8. Good. Whoops, sorry. I realize you can't see that. That's one way. Good. Does anyone have another way of going about it? Everybody give it up for Lydia. That was one way. Lydia? Oh, that's good. Good. Okay, so she said we could also use the slope, y1 minus y2 over x1 minus x2, and then... Good, good, excellent. Okay, okay, does anyone have another way of approaching this? Do you want to see another way of approaching this, or are you good? Yes, you want to see another way?
Yeah.
Okay. Since when we are looking at formulas here, that's the midpoint formula. Okay, so it's telling us that the midpoint is -4, -2. So we're going to actually take that and substitute that in for m, which represents the midpoint. They also tell us that one of the endpoints has coordinates -8, -12. So we can plug -8 and -12 in for x1 and y1, and then use those to solve for x2 and y2. Okay, so let's see. So x1 is -8, x2 over 2, and y1 is -12. Whoops, I put a comma in there. You can ignore it. For 2. Okay, so how do I use, what would be the next step in this if I'm trying to solve this for x2 and y2? What would I do? Would you all agree that this is an x-coordinate, my little cloud? Would you agree that this is an x-coordinate? Does the equal sign mean that they're that they're equal to each other? Can I set them equal to each other? Okay, let's try that. So let's see. -4 equals -8 plus x2 over 2. So how would I go about solving this for x? How do I get x by itself here? Good, that's good. Multiply by 2. So we get -8 equals -8 plus x2. Then what? Add 8. So x2 equals 0, which matches, if we look at our graph, the x that we ended up coming up with over here is at 0. So that's good. Okay, now how would we use that same approach to find the y's? Marcy?
Would you put -2 as your m and then
Good.
plug in 12?
Good. Right. Exactly. Cool. Everybody give it up for Marcy. So then we multiply, same set of steps to get y2 by itself. -4 equals -12 plus y2. And then if we add 12 to both sides, we get y2 equals 8. So if we actually go back and put that in coordinate form, 0, 8, which again we got when we graphed and counted spaces. So, multiple ways of doing that. Questions? Okay, last problem. What? Okay. Last one. Use the distance formula to show that P, which is at -4, 1, Q, which is at 5, 4, and R, which is 2, -2, are vertices of an isosceles triangle. Okay, we are actually being told how to do this problem. There may be a variety of ways of doing it, but since it's specifying use the distance formula, we want to use the distance formula in some way. Let's first review, though, what is an isosceles triangle from geometry? Nick. Excellent. Everybody give it up for Nick. Okay, so he said 2 congruent angles. Anything else that goes along with that? Yeah, Marcy?
2 equal sides.
2 equal or congruent sides. Okay, excellent. Everybody give it up for Marcy. Okay, now, how can we use the 3 vertices that were given in conjunction with the distance formula to verify that this is an isosceles triangle? Any ideas? Well, if we want to find the distance between each of the points, that would give us the length of each side, right? Meaning if we wanted to find the distance of PQ and the distance between QR and the distance of PR, each of those, and then compare them. If we have an isosceles triangle, that means that when we calculate these, two of them should be equal to each other, right? Okay, so for PQ, that's these 2 points, we have -4, 1 and 5, 4. So remember the distance formula is x1 minus x2. So for P and Q, that's -4 minus 5 squared plus y1 minus y2, or 1 minus 4 squared. Okay, so -4 minus 5 is what? -9 squared, which is 81. And 1 minus 4 is -3 squared is 9. So this one comes out to the square root of 90. Do we need to simplify? If we're just trying to figure out if this is an isosceles triangle or not, do we need to simplify? No? Why not? We've always said you want to simplify as much as possible. Why does it not matter in this problem? Akashni? Right, exactly. Everybody give it up for Akashni. So she said we just want to figure out which two sides are the same, or if there are two sides that are the same. Okay, now if I'm doing the same set of steps but with the points Q and R, can somebody fill this in for me? So Q and R, so we do x1 minus x2 squared and all of that. Do we... Okay, so do we understand? And we just don't want to talk. Is that what's happening? Or do we not understand what's going on? Okay, raise your hand or clap, since we are audible here. Clap if what we're doing makes sense. Okay, so would you like me to just go through it then? Okay, so with Q and R, we do 5 minus 2 squared plus 4 minus -2 squared. So that comes out to 3 squared is 9. 4 plus 2 is 6, squared is 36, 36 plus 9 is 45. So the distance between points Q and R, side QR, has a length of the square root of 45. So that means this last one should either have a length of root 45 or root 90, if it's an isosceles triangle. Okay, the last one, P and R. So now we're looking at these 2 points. We get -4 minus 2 squared plus 1 minus -2 squared, which comes out to -6 squared, which is 36, and 3 squared is 9, so that's the square root of 45. So, you guys tell me, do we have an isosceles triangle? How do we know that? Good, 2 of them have a length of root 45, so it's these 2 that are the same length. So that would be our proof that we do have an isosceles triangle. All right, any questions? Okay. So everybody go ahead and start your homework that is listed right there.